Hello, I'm Vimsar. This is the stage 2 circuit of the assignment 2 project. The circuit operates as a minute counter and JK flip-flops are configured according to ripple carry configuration, forming a ripple counter. And the two displays are connected to two splitters, and the display goes from 0 to 59 and resets afterwards. Let me show you this. So as you can see, the display goes from 0 to 59 and resets afterwards. What actually happens is that when the clock reaches 59, the AND gate detects this and resets all the flip flops to 0. Thank you, and I will pass it to Bime.
Thank you, Mr. And this is stage 2 of our assignment 2. We have configured our flip-flops in repertory configuration, and I have used two AND gates to reset it after the 59. And I have used two splitters to control the signals. And we can start it from the set time and click in the clock by manually or automatically. I will show you the first the manual way. Like this. As you can see, it decrements by 1. And if I want to enable the auto clicking, I can use Control K, as you can see. And after that, I can turn on the control switch to turn the K flip flop. And if I want to pause the display, I can use the stop clock button like that. If I want to manually increment the display, I can use the set time button like this. I can manually increment that and change the number of the display. And that's it. Thank you, and I will pass it to Chirag.
Hi, I'm Chiran. Let me explain the demonstrate stage of our Elam Pro project. In stage 3, we added the flip-flop, logic gates and the reset logic to manage our counter and synchronize it with the minute counter. Here's how it's work. A minute counter counts from the 0 to 59. When it ceases to 0, it sends a pulse to our counter. Our counter increment by the one of each pulse, and first digit counts 0 and 1, 0 or 1, and the second digit counts 0 to 9. Logic gates reset the hour count to 1 after reaching 12, maintaining the 12-hour system. The new circuits ensure smooth transition and accurate timekeeping. That's a stage 3 our project. Now I'll hand it over my friend Kim Hana. Thank you.
Thank you, Chiran. And in the fourth function, which is the AM/PM switching, I'm using a JK flip-flop as the switching method. And every time the 8-bit and 4-bit of the hour counter is activated, it will receive a clock signal which will switch its output between AM and PM. Allow me to demonstrate. Eleven and 12. See, right there. And again, 11 and 12, right there. In this alarm clock function, this whole part is basically the same as the regular clock, but without giving it a regular clock signal. And you have to manually change the time with this a minute and hour counters. And once you set the required time, you can set the alarm with this button here, which will send a clock signal to these D flip flops, which I've added for every variation of the JK flip-flops in the normal circuit. And once you press the set alarm button, the D flip-flops will register those variations and store that data, which I will later compare with the JK flip-flop variations of the normal clock. And once the circuit finds an exact match of the variations, the circuit will activate and the alarm will go off. Here, I'll set the time to, let's say, 2:20. Okay, and here I'll set the alarm. The alarm recorded the time variation, and here I will manually count the time. Pay attention to the alarm bulb, alarm indicator. Okay. The alarm will go off exactly when the times are aligned with each other.